Okay, this is another analytical geometry question, the last one before the control test that I think hits on some of the real important things you have to know. So let's just give it a try. Here we have 3 points are given. A is -4 minus 2, B is -1 minus positive 2, C is 2 and 0. The first question, determine the gradient of AB and the gradient of BC. Okay, so let's try the first question. Well, the gradient of AB, just start with either point, but this one will be, if I go y2 minus y1, it'll be 2 minus minus 2, it'll be 2 plus 2. And -1 minus minus 4 will be -1 plus 4. And that'll give me 4 over 3. That's the gradient of AB. Now, the gradient of BC, we just do the same thing, 2 minus 0 on the top. That's y2 minus y1. And x2 minus x1 minus 1 minus 2 on the bottom. And there we have the gradient of BC, minus 2 over 3. We've got these two gradients, and we're going to use them to answer some of the other questions. Let's take a look. The second question is AB perpendicular? Is AB perpendicular to BC? Well, the answer is no. No. And the reason is because if you multiply those gradients together, they do not equal -1. If they equal -1, then they'd be perpendicular. But because they don't equal -1, they're not perpendicular. Okay, let's take a look at the next question. This one's a little trickier. Determine the angle ABC. The angle ABC. Well, these are like 4-mark questions. And one thing, if you want to get at this angle, you're going to need the angles of these lines. In fact, the angle of inclination is what you need to get at these lines. So if you just do this one thing, if you're given a gradient is really the same thing as a tangent, opposite over adjacent. So if you go shift tan of the gradient, you'll get what's called the angle of inclination. The angle of inclination of AB, that's a positive gradient. Shift tan of 4 over 3, there's your answer. There's a mark. It's that easy. But the angle of inclination of BC, you just do exactly the same thing. Shift tan of -2 over thirds, you get a negative number, but you have to add 180. The angle between the horizontal and this line here is a big angle. It's 146,31. But just go shift tan of the gradients, you've got half the marks. Okay, now what are we going to do with these gradients? Well, there's a thing here. If you stop right there, if you look at this horizontal right here, that 146 degrees is the big angle for BC right there. Now, the angle of inclination is bending up. That's that 53.13 degrees is right there. Well, hey, this is the exterior angle of a triangle. And these two angles have to add up to equal this exterior angle. So to get my answer, all I have to do is subtract these two answers. And that's the answer. That angle ABC must be 93.18 degrees. And the reason is the exterior angle of a triangle. Now the last question is, determine the equation of the line CE. This line CE, if AB was parallel to CE. Well, the deal is, if AB is parallel to CE, it means they have the same gradient. So the gradient of BA must equal the gradient of CE, which is 4 over 3. Now, if you want to find the equation of a line, all you need is a gradient and 1 point. And that's all you do. You put in the gradient of 4 over 3, and you put in the point C, where x is 2 and y1 is 0. And then just multiply it out. 4 times 2 is 8, so it's 8 over 3. Y minus 0 is y. There's the equation of the line that passes through CE. And that's it. If you understand these 4 things, you might want to pause the video right at the beginning and try all the questions, and then look over to see how I did it. Okay.